you have understood the things, then it will be easy for me to proceed. Okay, so as we have already waited for some time, so we'll be starting now. So if you still have any doubt from the previous modules, you can please let me know. Or otherwise, we'll today start with the third module, that is about high energy rate forming, in short known as HERF, HCRF. So the full form of HERF is nothing but high energy rate forming. So after the last class, in this last module basically, so whatever things we have basically discussed, those are we have discussed all the things about like different types of forming processes. There we have seen what are the fundamentals of all those different forming process. Okay, what happens in forming. So what are the different types of working involved, like hot working, warm working, cold working, etc. Similarly, we have discussed after that different types of forming, like all those forging process, extrusion process, all those processes we have discussed along with their advantages, capabilities, and limitations, etc., and what we can process with them. And we have seen the main two classification, like the bulk metal deformation and the sheet metal working also we have discussed. And there in the sheet metal working, we have discussed about different possibilities of processes, sheet metal processing, the difficulties involved, what is spring back effect, etc., etc. Okay, so all those things we have discussed. But in those all those forming processes, the formability aspect, or you can say the process of forming, it was not that much fast, and the amount of pressure or the amount of energy or ultimately the forces involved, that depends on the varies from the process to process. But like the instance or the amount of energy or the time duration for which the energy is involved, it was it was different from that of whatever we are going to discuss today in the HERF processes, or you can also known as the high energy rate forming, or sometimes also known as high strain rate forming. Okay, and there is another name for this particular process, high energy rate forming or HERF. That is, we also use high velocity rate forming. Okay, so these are the some synonymous names for this particular process, which is in short the most of the one of the very like you can say widely used word is HERF. Okay, even though we have some other names for it, like high velocity rate forming, high strain rate forming, etc. And today we are going to discuss why what is this particular process, how this is basically done, and how it is different from the other conventional forming processes, and why we are discussing it as a another type of in a different module itself, you can say. Already in the second module, as we have discussed, like all those forming process, you might be wondering why we are considering this as another module and we are distinguishing like we are discussing like that. And directly this high energy rate forming or HERF process we have not categorized in our normal forming processes. Okay, so there we have considered like all those bulk deformation processes, those things we have discussed separately, and separately about our the sheet metal working process we have discussed. Now, what is this HERF, or what is this high energy rate forming, or what is this high energy rate or high energy rate? All those words are involved. Why these words are involved? Those things we are going to discuss today. So basically, what happens here is, so as from the name itself, it indicates. So that means it's once again it's a kind of forming process only. That means you will have the parent material, okay, which may be mostly in the form of seeds and all, okay, and ultimately from that particular material, okay, that is a workpiece we are talking about, okay, working material, okay. So as from the name itself indicates, that means some high energy rate or high energy is involved. Okay, so I believe rate, all of you understand what rate means. We are talking with respect to time. Okay, high energy, all of you can very easily consider, that means amount of energy involved will be high, and rate means that is kind of we're talking about with respect to time, that is fast, slow, or like that. Okay, or whether the energy is being supplied for a very at a faster rate or like that. Okay, so that kind of thinking or that kind of phenomena will be involved. Okay, so now how we can define this HERF processes, or what is this? So now this HERF process, that is high energy rate forming, okay, in this it's a type of forming process only. Okay, but how it is characterized? It is characterized by the large amount of energy which is applied for a very short interval of time. So now how, like I believe all of you can now distinguish like what is this particular HERF process, and like the why how it is different from the other type of forming processes that already we have discussed. So now here in the HERF processes, It's a forming process where a very large amount of energy is applied for a very short interval of time. Now, what basically happens if we do that? So, see, if we are talking about different metals, okay, so like if we already know about all the stress strain curve, okay, and there is a tendency of the material to deform more readily, okay, more readily under the extra application of load. And as in this particular process, we are talking about using a large amount of energy within a short interval of time. Okay, so because of this particular applied energy, the extra load application will be there. Okay, and it makes the process very useful to form large size parts. Okay, the size of the parts that we can do here is very large size parts out of most of the metals. Okay, most metals. And previously, what the metals which were previously difficult to form in the conventional forming processes, those kind of metals also we can form in this particular by this particular HERF process, that is high energy rate forming process. So previously in the last module what we have discussed, so processing of all the metals, all the type of metals from the all those available metal forming processes, mostly we are talking about right now, suppose bulk forming process, okay, or sometimes with respect to sheet metal process also. So it was not always possible, and it was the processes were limited by the application of the energy or the loading that will be required, and to give that particular type of loading or to apply that much amount of pressure or force, you can say. So in that particular case, all those tooling or tooling or equipment that will be involved will be of high load capacity, has to be very high load capacity. Okay, they becomes bulkier and all. So all those difficulties were involved with respect to if we require, suppose if we are trying to process difficult to form materials, okay, and if we have to somehow form them, then the tremendous amount of energy will be required. Okay, we have to supply all this like that much amount of energy which will be able to deform it. But if we are talking about applying that much amount of energy with the conventional type of forming processes, then what will happen? I already know, depending on the type of metal that we are working, depending on the difficulty of forming, we have to apply that extra loading. Okay, and if we are talking about the conventional type, not the HERF, if we are talking about this conventional methods, then all the tooling, etc., that will be involved will be of very heavy duty tooling that we have to use, and the energy requirement will be high, and ultimately the cost of production will go up because of the tooling itself. There will be like heavy machineries we have to use. Okay, the power requirement or the loading requirement will be high in that particular place. All starting from the all those clamping, etc., everything has to be high heavy duty. Okay, so those are some of the difficulties if we are talking about uh, going for difficult to form metal with the help of the conventional forming processes. But here, as the like in the process itself, there will be some like process. Okay, there will be some techniques to apply large amount of energy, okay, very for a very short duration of time. And because of this extra application of load, they will be able to produce large size parts even from the difficult to form metals. Okay, so that is some of the advantage. Now, as we're talking of applying very large amount of energy for a very short amount of time, so basically what happens in the hard process, it is characterized by the forming of the parts at a very rapid rate. And because this processing is very rapid, okay, it's also known as the high velocity forming process. Okay, so another name for this hard process is nothing but the higher velocity forming process. Okay, so why it is ideally why it is known as the high velocity forming process, now it's clear to everyone. Okay, so this is another name. Next, I have discussed that it's also known as the high strain rate or like processes. Okay, so why basically high strain rate process it is called? So now see, as we are talking of deforming it at a very faster rate. Okay, so in that particular case, all of you already know what is strain. Okay, what is stress, what is strain. I believe all of you already know. There is no need to once again recall them. Okay, but as the material will get deformed at a very faster rate. Okay, so that means the strain involved or the strain rate involved will be very high. Okay, that's why it is also known as high strain rate forming processes. Okay, because at an instant the material the material will get deformed and it will correspond to the whatever is the shape that you require and that you give with respect to the die. Okay, now what are the advantages? So there are several advantages of using this kind of forming process, like the die cost are certainly low, okay, maintenance of easy maintenance of tolerance, and one of the very major advantages possibility of forming most of the metals and materials which generally doesn't show spring back effect. So the as in the sheet metal processing we have considered that we have basically discussed about the spring back effect, and there we have seen how why the spring back effect makes forming of process different parts difficult. Okay, so those things already we have discussed, and here you will see sometimes even we can get rid of even the spring back effect. There will be like very less chance of having spring back effect. That kind of possibilities also is there. And similarly the production cost of the components by such process sometimes becomes low because of the like faster rate of production, etc. Okay, but there are certain limitation also. So the limitation is like as we are talking of applying very high energy rate at a very short interval of time, okay, producing and applying high energy with a very short interval of time. So basically later on you'll see there are different techniques to like three or five different distinct methods to apply this high energy, okay, to get this high energy rates. And there will see that it's sometimes it even involves the use of explosive, etc. So one of the limitation is we need very skilled personnel for it, okay, and the safety requirement in this kind of processes is kind of very high. Okay, we have to, if when you'll see there are methods like explosive forming in HERF or high energy rate forming. One of the method is kind of explosive forming. So in that particular case as we are will be dealing with explosives and all, so basically it becomes our safety is becomes one of the prime concern. And we have to stick to all those gov regulations and all, okay, because we'll be talking of like using explosives and all. Okay, so those are some of the limitations. Okay, now up to this much is it clear everyone, what is this HERP, why it is required, or how it is distinguished from the other forming processes? Please let me know someone. Someone may please let me know whether up to this much you have understood or not. Okay, okay, thank you. So now we are saying that we have to use high energy rates, okay, to produce the required energy at a very fast rate. Okay, we should be able to get the high energy rate, and that has to be produced somehow. Okay, we need to produce it, then only we'll be able to put into our use. Okay, and thus we'll be going for suppose a particular HERF process. Now there are certain five distinct methods by which we can very easily get the high energy rates which will be required in these processes. Now some of them are like this kind of high energy rate it can be obtained by the explosions which are made underwater or in some other fluid. Okay, it's not only always water, okay, but other fluid also is possible. But as water is very readily available, very cost effective also, we make some explosion underwater, and by thus we can get the high energy rate. So I believe all of you have maybe in movies, or maybe if you are unfortunate enough, maybe in real life also you might have seen explosion, or maybe most of you are playing games and all, you have you throw all those grenades or whatever explosive you use, and basically what happens in the explosion, okay, a a very high energy is being released within a fraction of time. Okay, so that rate of production of energy in explosions, that means it is high. So these particular explosive methods, okay, or these explosions, if we can if we can control, and if we like apart from like in general you see the explosives and all which are being used for destructive purpose, but these things, this explosive, we can also, you'll see how we can even put this kind of explosive, the energy that is involved with explosion, to our use to form some desired parts. So that will be some good thing, that will be some good use of explosive. Similarly you might have seen or you might know about the all those use of dynamite, etc., in the all those mines, sometimes to clear the pathways and all, or to sometimes make like in the tunnels, etc. Okay, we even used like dynamites and all that kind of explosive. Okay, so those are also kind of some constructive method, even though we destruct the like destroy that particular part, but suppose those are for some good reasons. Okay, so that means if you are not using it for antisocial purpose and all. Okay, if you're like put like all those rules, regulations, etc., if you're abiding by and you are taking permission and you are using it to some good use, then explosive can be useful also. So you'll see how with the help of explosion we even make this kind of form part. Okay, so that is one method. That means by the explosion which are made underwater, that means in controlled environment, we can get the high energy rate which will be recovered. Similarly, we can have some underwater spark discharge methods. Though by the discharging of sparks, okay, we can get a within a fraction of time we can get a high energy, and that energy can be put to use for forming the parts. So this can be one way. So basically this particular process is kept in the that is used in electrohydraulic technique. Okay, so electrohydraulic HERF method. Similarly, by the using of some pneumatic methods, so which is nothing but a kind of mechanical means. Okay, we can go for producing this high energy rate. And similarly we can go for like by the use of the internal combustion of the mixtures of different volatile gases, we can get a amount of high energy within like a time, within a small time, that is high energy rate. And some by the use of some rapid force magnetic fields, okay, that is electromagnetic methods. So by that also we can get the required high energy rate. So these are some of the methods by which we can obtain that high energy rate, which we can put to use in these different hypotheses. Now, depending on the different types of ways by which we are actually producing the that high energy rate that will be required for in this particular processes, and depending on the setup and all the techniques involved, so we have got different different methods under HERF. So basically HERF, what is HERF? What have you understood by now? Can anyone let me know what is now your understanding about HERF process, how it is different from the conventional manufacturing forming processes? Yes, you have understood or not? Okay, thank you. So now what are we'll be discussing some of the advantages of this particular process. Already we have discussed one or some. Okay, now once again some advantages. So with these hard processes, it's possible to form very large workpiece and difficult to form material with less expense. Okay, and this equipment and tooling which we use in hard processes, it is economical also. Okay, and there is less difficulty to deform metals having spring back effect. Okay, so we have seen that in normal forming, so spring back effect is one of the like concern. Okay, it makes our deforming of the metal becomes difficult. Okay, but here in these hard processes, there is less difficult to deform metals which shows spring back effect. Why basically we have less difficulty in this particular processing of spray of metals which shows spring back effect? So it basically are like within these two factors. So in this particular process, okay, what happens as we are talking of using a very high energy and all within a short span of time. So now, what we generally have, as we are talking of this particular forming process, so here also we'll be having a separate die, okay, and the is just like the other forming process, the like material, okay, that is the workpiece, it should conform to the shape, okay, and once that particular process is done, it takes the shape of the die. Our process is basically over. Those are nothing but the any normal forming process, okay. But here the application of energy, okay, that is different. The how we apply the energy, the amount of energy that is involved, the way we produce the energy, or the way we do the process, that is different than that of the conventional processes. So in the conventional processes we generally have all those hammer punches, etc., which directly applies the force. But here as we have the different techniques to produce the high energy rate that we have discussed, we generally put those techniques to use, and they produce the they give us that particular amount of energy that will be required, which is very high rate. Okay, the amount of energy is high and it is applied for a short duration of time. That means the rate of energy supplied is very high. Okay, and because of that, if we are talking of this using the die, so here very high compressive stresses will be set up in the metal, and because of the use of this very high compressive stress, okay, it is forced against the die, but the amount of it is like due to the involvement of very high energy rate, so very high compressive stresses are set up in the metal when it is forced against the die. Okay, now because of that, what happens? Suppose if I have suppose this particular shape of the die, okay, suppose this cup shape kind of thing, okay, suppose previously I have this particular sheet, and after deformation, if it gets like this, when it conforms to this particular shape, suppose this kind of shape I will get. Okay, this is the final shape, the required shape. So basically what happens, as suppose somehow we are producing the high energy, maybe suppose explosive or whatever, so it will propagate the energy will propagate, and it will actually get applied to this particular metal, which because of which it will get deformed, and whenever it reaches the bottom part, okay, suppose this particular face of this particular die, separate die, so basically here when it is forced against the die, very high compressive stresses will be set up. Okay, because the amount of energy and the rate at which we are applying is very high. Okay, and because of that particular very high amount of energy, that or high energy of compressive stress which will be set up even on the die also, because of that what happens, some slight elastic deformation of the die also occurs under the ultra high pressure. So initially if the die suppose something like this, okay, that is suppose this kind of shape we wanted, so because of the application of the ultra high pressure, even the die also gets deformed, so it is exaggerated. Suppose now under the ultra high pressure, suppose this becomes the momentarily this becomes the shape of this particular die, so that means it has the die itself has get deformed because of the very high ultra high pressure. Okay, and now because of that what will happen, because of that ultimately the workpiece, which initially we wanted that it will deform like this, but as the die itself has got deformed, so under that condition the workpiece also will get, okay, there will be, it will result to some slight overforming of the workpiece. The workpiece will overform. Okay, and it will appear like, and ultimately it appear like there is like no spring back that has occurred. Okay, so that means even in the spring back, what we know, in the spring back effect we know that under when we uh, remove the loading, okay, the material tends to spring back. Okay, some amount of plastic deformation that is with some amount of deformation we lost. Okay, but here as the material itself gets extra deformed, some extra deformation will be there. So because of that ultimately even if there is spring back, so we can have apparently there is no spring back, because already initially it has got overformed, and after that if suppose some spring back also was there, there is no problem. Apparently there will be apparent spring back effect, there will not be any apparent spring back effect. So it becomes easy to form materials which even show spring back effect by this particular process, because inherent to the process itself some die deformation will be also there, and you will see mostly the application of loading, that is the higher the energy that will be associated here. Okay, so they generally propagate uniformly throughout it, so the deformation of the die also gets, it is somewhat uniform. Okay, it conforms to the shape of the initial shape only. Okay, but some overforming. Okay, so because of that actually whatever problem of spring back it was initially there, it will be apparently there will not be any spring back effect after. Okay, so have you understood this thing? Why it becomes easy for us to even form the very difficult to form materials by this hard process, as well as how it becomes easy for us to work with the materials which shows spring back effect in hard process. Is it okay? Have you understood or not? Let me know. Someone may please unmute and let me know. Have you understood or not? Okay. So, okay, so if you have understood the things, then this is basically about the introduction of all those herbs. So, in the next class, from next class onwards, we'll be discussing about the different types of herb processes. We'll start from the explosive farming, where, as I have discussed today, so we can even use some explosive materials to like to our put into use. It can be put into use, so that particular type of process will be known as the explosive forming process, where we'll be using the energy that will be produced by some explosion. And how we do that, what are the different techniques, those things in the from the next class onwards we'll be starting it. Okay, so with this we'll be stopping here today, and if you have any question from today's class, you can ask me for now, or if you have understood properly, and also you can let me know. So what we have discussed today, so basically about we have what is HERF, what are the how it is different from the normal farming processes, what are the advantage of it, what are the kind of, you can say, precaution that we have to take, or some you can say limitations, that kind of thing. Okay, the ways to produce the required high energy rate, how we can produce that, and how it can be put to use. And similarly, the one of the major like advantage, like how it becomes easy for us to process the difficult to form metals with HERF. Similarly, how it becomes easy for us to process the metals which even show spring back effect, and ultimately apparently that will not get any spring back effect, and how it can be done, and what is the process involved, what is the mechanism involved underneath. So those things we have discussed today. So with this we stop here, and if you have any question you can let me know. Okay, no question. Okay, then we'll stop here. So thank you everyone for joining this class. Thank you.